When I look at this differential equation, one of the things that we want to do in order to solve it is to kind of classify what kind of differential equation it is. First of all, that y prime, we probably want to rewrite as dy dx. Now that I'm looking at the problem, that means y is my dependent variable, x is my independent variable. So when I look on the right-hand side of that equal sign, if I only had x's involved, then we would call that a pure time differential. Or if I only had y's involved, then I would call that an autonomous differential equation. Because I have both, now I'm looking to put it into one of two categories, either to see if it's separable or first order linear. Now, to check to see if it's separable, we would be looking at this right-hand side to see if we can separate the parts with x's from the parts with y's. And specifically, we're looking to write the right-hand side of that equation as a function of x times a function of y. So when I look at this, I can group that x sine x together. There's my function of x. And that's being multiplied by y over y plus 1. That's my function of y. If I've got multiplication between that function of x and function of y, then I know it's separable. And the way I'm going to separate it, I'm going to divide this right-hand side by all of those y terms to get them over on the left. And I'm going to multiply both sides by dx to move our dx piece over here so that we can take the antiderivative of both sides. I don't really like dividing by fractions. It always makes me nervous. So instead, I'm going to multiply by y plus 1 over y, so that my y plus 1s will cancel out and my y's will cancel out. And I'm going to squeeze that in over here too. So I had our dy dx. And then I'm going to go ahead and multiply this side by y plus 1 over y. I'm also going to multiply both sides by dx. The result is going to be that on the left-hand side, I've got y plus 1 over y dy is equal to x sine of x dx. This is considered separated because I have only y's on the left-hand side and only x's on my right-hand side. Once it's separated, I can go ahead and integrate both sides. This integral over here, I've got a mixture of algebra and trig. There's no u substitution that's going to help me out of that. On this side, we're definitely going to have to integrate by parts. On the left-hand side, because this is only algebra, I'm going to want to rewrite this to look like y over y, or 1 plus 1 over y. This side looks pretty easy to finish off, so I'm just going to go ahead and do that. If I integrate 1 with respect to y, I'll get y. If I integrate 1 over y with respect to y, I'll get natural log of y. On the right-hand side, this one I'm going to need to use integration by parts. So if this is a mixture of algebra and trig, and kind of off to the side here, I know I'm going to let that algebra part be equal to u. Which means my dv is sine of x dx. When I take the antiderivative to get my v back, the antiderivative of sine is going to be negative cosine. And when I take the derivative of x, I'll get dx. Putting that into our integration by parts formula, I'm going to have u times v. So that'll be a negative x cosine x minus the integral of v du. So that minus sign and that minus sign I'm going to turn that into a plus cosine x dx. So I've got negative x cosine x, and the antiderivative of cosine is sine. Now, when we get to this point, this is a general solution to the differential equation. It's a general solution because it still contains this constant. It doesn't have to say y equals in order to be a solution. This is an equation that satisfies the original differential equation. But because we were given an initial condition, we are going to want to go ahead and solve for that c. So this initial condition tells me that when x equals 0, y should equal 1. Plugging that in down here, I am looking at 1 plus, well, natural log of 1 is 0. X was 0, so that'll go to 0, and sine of 0 is also 0. So it looks like c should be equal to 1. And because I don't really have space to rewrite this, I'm going to go ahead and erase that bottom line now that we know that c is equal to 1. And plug it in right here. So this would be our solution. Just as a note, there is no way for us to rearrange this to make it say y equals. There is